This video is a review of class on September 3rd, 2020. We had a few technical glitches, particularly in fourth hour, so this is the latter half of class, which was new information. So I talked to you about this relationship sheet. This is found on the website homework page, howchem.net, homework page for advanced chemistry. Click there and you'll find metric relationships. These relationships you need to know. The word thing here, when I use things, I'm talking about, that's a generic term for whatever unit you happen to be talking about. So I'm just going to show you how it applies with the prefix centi. So if my thing I was talking about was a meter, then the relationship would be 100 centimeters is equal to 1 meter. If the thing I'm talking about is a gram, then we're talking about 100 centigrams. If the thing I'm talking about is a day, you never hear about anybody talking about a day in these terms, but it would apply. Centi just means 1/100th, so 1 day is 100. In a practice activity I'm going to refer you to, there's another way to write this. You could say that 0.01 meters equals 1 centimeter. And that's another way to say that they're equal to each other. So centi means 1/100th of whatever you're talking about. So no matter what you're talking about, centi means 1/100th. In the same way, milli means 1/1000th. So if I had 1,000 milli things, so 1,000 millimeters would equal 1 meter. So these are just metric equivalencies that you need to know in order to do conversion factors. I also wanted to spend a minute talking about cubics, and we didn't get to that in fourth hour, we did in sixth. So here's a little bit about cubics. I'm going to draw a cube here. It's not going to be the most wonderfully artistic cube that you've seen before, but there it is. All right, if each side of the cube is 1 meter, we could also say that each side of the cube is 10 decimeters, and each side is 100 centimeters. So we know that one thing is 10 decithings, so 1 meter is 10 decimeters. We know that one thing is 100 centithings, so 1 meter is 100 centimeters. That's how the things sheet ties together. Now I want to consider the volume of the cube. We know that volume is equal to length times width times height. So if I ask you what is the volume of the cube in cubic meters, you would say, well, it's 1 times 1 times 1, or 1, and the unit would be cubic meters, because if you're cubing it, 1 meter to the third power would be 1 cubed, and also meters cubed. So the 1 cubed is just 1, but meters to the third power is meters cubed. If we do this in cubic decimeters, then 10 decimeters is one side, so the volume would be 10 times 10 times 10. That would be 1,000 cubic decimeters. So 1 cubic meter is 1,000 cubic decimeters. If we do it in centimeters, it's 100 centimeters this way, 100 centimeters that way, and 100 centimeters deep. So we're really looking at 100 times 100 times 100. Which is 1 million cubic centimeters. And if you think about a cubic centimeter is about the size of a little dice. You're familiar with rolling dice. So 1 die is about 1 cubic centimeter. In your house, a washing machine is kind of similar to 1 cubic meter. So you could put somewhere around 1 million individual dice into your washing machines, the amount of space your washing machine occupies. Which is always, that's kind of a surprising number to me. It's a big number. All right, so 1 cubic meter is 1,000 cubic decimeters, and it's 1 million cubic centimeters. Now, if we I want to consider now what is a cubic decimeter. 1 cubic decimeter is equal to 1 liter. So just trust me on that. 1 cubic decimeter is a liter. So if I was going to be looking at a cubic decimeter, it would look like this, a little smaller cube. and that'd be 1 decimeter on the side. Well, 1 decimeter is 10 centimeters. So if I'm looking at the volume of the cube in cubic centimeters, the volume equals 1 cubic decimeter, because I drew it a decimeter on a side. It would equal 1,000 cubic centimeters. It'd be 10 times 10 times 10. So 1 cubic decimeter is 1 liter, equals 1,000 cubic centimeters. There's a prefix milli here. 1,000 milli things is a thing, so 1 liter is 1,000 milliliters. So if 1,000 milliliters equals 1,000 cubic centimeters, that means that 1 milliliter equals 1 cubic centimeter. You need to know that relationship. 1 milliliter equals 1 cubic centimeter. And then, of course, 1 decimeter cubed equals 1 liter. 2 relationships that are important, tying together different units of volume. All right, so that was a little review of metric relationships in cubics. In class, I was working with this sheet, and I was trying to teach you how to write 1 using ratios and units on the thing sheet. So if I'm going to look at 10 and 1, I know that I have on here 10 decithings is 1 thing, so I could say 10 decigrams is 1 gram. I know that 100 is here, 100 centithings equals a thing, so I could say centiliters and liters. And it doesn't make any difference whether you use liters or meters or grams or whatever. The prefixes mean the same thing. 1,000 is with milli, so 1,000 milliliters, 1 liter. Conversely, you could say 1 liters, 1,000 milliliters, or I could say 1 meters, 1,000 millimeters. Here I could say 100 centimeters is 1 meter. And this one's an easier one maybe because you recognize that there are 7 days in 1 week. That's 1 way. There are other things you might be able to use, but 7 days is equal to 1 week. So the point is all of these equal 1. On the bottom, you know, 60 seconds is an hour. Or you could have said 60 minutes. Oops, 60 seconds, not an hour. 60 minutes is an hour. Or you could say 60 seconds is 1 minute. Here, 36 inches, 1 yard. 1 times 10 to the 6th, that's on our things list. 10 to the 6th means a million. That's micro. So 1 liter is a million microliters. We represent micro with this little U-looking symbol, kind of like a U with a tail on each side. That's a Greek letter mu, M-U. Here, 12 and 1 may be inches and feet, would be easy to understand. Here, there's a comma there I missed. That's a billion. So we could use meters and nanometers. Maybe you've heard of nanotechnology that's people are working with now. It's biology on a cellular level, trying to get really, really small particles to go into our bodies and act sometimes like even little robots inside our body. And then 365, you could just say days and year. So all of those are equal to 1. The reason they're equal to 1 is because tops and bottoms are the same. This is another problem set you'll find on your worksheet, or excuse me, on your website. Here I put the units in. So if I put meters and centimeters, I could say 1 is 100, and that equals 1. I went through the cubics a minute ago. This was 1,000,000 to 1. So 1 cubic meter was 1,000,000 cubic centimeters. And that was, remember, the cubes, because if it's a cubic meter, 1 meter, 100 centimeters, it's 100 times 100 times 100. 1 kilo means 1,000 things. So 1 kilo thing is 1,000 things. That's right here. 1 kilo things, 1,000 things. So 1 kiloliter would be 1,000 liters. So 1 kilo things, 1,000 things, 1 kiloliters, 1,000 liters. Grams and nanograms, come down here. Nano is billion. So 1 gram is 1 billion nanograms, and that's 10 to the 9th power. 1 meter, 1 times 10 to the 9th nanometers. Micro, we said that was a million. 1 times 10 to the 6th, or a million microliters in a liter. Down here, if you're going to make them equal 1, 1,000, 1. 1 liter, 1,000 liters is 1 kiloliter. This is kind of a weird one because this is millimeters, so going back to this same cubic meter, that's 1,000 millimeters on the side. But it's 1,000 times 1,000 times 1,000 for cubic, so one of these is 1 times 10 to the 9th. This, you're supposed to remember that 1 milliliter is 1 cubic centimeter. One of these was 1,000 of those because of this. If it was 10 decimeters is 1 meter, then 10 times 10 times 10 is 1,000. Hertz and gigahertz. So giga means billion, so a giga thing is a 10 to the 9th thing. So 1 gigahertz is 1 times 10 to the 9th hertz. Then grams and decigrams, 1 gram is 10 decigrams. And that's based on our things list. So that's writing 1. So what I was hoping to do was get us to the point where we could do some dimensional analysis using the idea of multiplying by 1. So there's a video that I want you to watch, and you might pause this video and watch the video that I have marked on my website. I'm going to show you where it is here. So watch this video on Intro to Dimensional Analysis from the University of Wisconsin. Please note that there was you'll find one math mistake if you work out all the problems, but I don't remember what it was now, but I remember in 6th hour we found a mistake there. After you've watched the other video, come back and watch what I'm about to show you. So pause one, start the other, and here we go back on dimensional analysis. Now I'm going to pull off this window, and we're going to take a look at, hopefully I can do this. All right, I think I can do it right this way. So I'm going to show you how to change, say, kilogram into milligrams. Okay, so here's how you would do that using dimensional analysis the way I want you to do it. So you have 1 kilogram. When we do dimensional analysis, we want to cancel the units that we need to eliminate. So we're going to, since kilograms are here, if I put them on the bottom, then I end up with kilograms divided by kilograms, and that equals 1. So they cancel. I don't know the relationship on my things list between, remember I'm trying to do this one, kilograms and milligrams, but I do know that a kilo thing is 1,000 things, and I know there's 1,000 millithings in a thing. So what that would mean is that if I put grams up here, I could say 1,000 grams is 1 kilogram. I still wouldn't be finished because I'm trying to get to milligrams. So I could put grams here and milligrams on top. So I put 1 gram and 1,000 milligrams. And the reason that we say that is because there's 1,000 millithings in one thing. So 1,000 milligrams in 1 gram. There you have it. So now I have 1 times 1,000 times 1,000, which is a million. And the unit is milligrams because grams and kilograms have both canceled. Okay, and there's my answer I got off screen there for you. All right, if I click Show Solution here, the answer is going to be the same. The guy that made this wrote it a little bit differently, and I'll show you how he did it. I think he did it differently. Yes. No, he did the first step was the same as me, and when he did the milligrams and gram relationship, he said that one of these is 0.001 of those. Is that true? Yeah, because a milligram is 1/1000th of a gram. So you can do it either the way I did it with, I usually say put 1 with the bigger of the 2 units and then decide how many of the smaller things match it. But if you wanted to, you could do one of the smaller units and what fraction of the bigger unit you have. And either way will work. The key thing is that you understand that the units need to cancel. So that's dimensional analysis. I would encourage you to try a few that are on this problem set. And those of you who are watching closely notice that I pulled this problem set from right here, the dimensional analysis practice. So on the website, if you click on Dimensional Analysis Practice, this will pop up. Each of these answers is worked for you. So if you, it's worked out for you when you, if you struggle with it. So if you wanted to change 7 dozens into how many donuts are in 7 dozen, and show your solution, you'll see there's 12 donuts per dozen. So 7 times 12 means 84 donuts. So we're trying to learn how to solve problems using this technique of dimensional analysis, which you did in physics. So it's not a completely new concept, but it's an important one for chemistry, so I take time to review it each year. All right, going to stop the video there. And once again, I'm in class at 12:30 on Friday to answer questions.